a little fan, and that's cutting around that fan. And that's depositing it. Of course, what it's trying to do is find the path of least resistance and smooth the bed. And you can see that it's starting to smooth the bed. So it loses its ability to transport, and it drops out the sediment, and then it has to work its way around it. Oh, now we're getting a little meandering runoff.
If you hadn't pressed it down, would it still do that?
Yeah, absolutely.
Just take a little bit.
Cut like that.
Mm-hmm. Now it's a question of whether it builds up that high enough to wind back here, or whether it's going to blow through there. I'll have to see. Pretty good. It's going to come through. Here we go.
Why is this so fascinating?
You just never get tired of it, right?
No, this is
Yeah, it's just fantastic.
It is.
And if you take a step back and you don't focus and you don't focus on a particular spot, it's really cool to see what, the sediment transport, and to
Yeah.
see what we want to try and reach is what we call equilibrium sediment transport, where we have sort of kind of uniform sediment transport down the whole bed, which we never actually get, because the sediment's always going to then rework a little bit more, or find some way to erode or deposit. But things are starting to happen. Still don't have a data point, but they're starting to happen.
It's a little lower.
A little lower?
Yeah.
Okay. How's that?
That's fine.
Right on?
Yeah.
Okay, cool. In the geomorph class, what I like to do is, once you have the full river established, we'll come back and do another run and bring the monopoly houses, and then everyone has to bet where they want to build their house with the best view, but not lose their house to the river. It's pretty cool.
Right.
Exactly, right? So silly. And the winner gets a Dutchess burger book for him or her. We've got some. So what we're going to try and do is we're going to try and catch the first pulse of runoff that comes out. And the sediment that's being transported could be completely artificial at that stage, because what I mean by that is you've got the discharge moving in here, but you may have a lot of sediment built up here, and it may just be like a slug, so the amount of, sometimes you get a big flush of sediment early on. That's what happens in real systems, or hill slopes in between storms, especially if you've got dry periods. Yeah, you don't have to worry about it yet. Yeah, you've got a little bit of groundwater seepage. So the first data point, when you get to your data, you may plot discharge against sediment, and it may be way out. It may not, but you still got to account for it. Now we're starting to see some incision of the runoff. We're getting close. We'll start. I'll give you the nod, Esther, but once it comes over this. What are we in here? We're at 18 minutes. Whoa, that's pretty.
It's already been 18 minutes?
Uh-huh. I know, right? Oh, it's going to cut off that little oxbow there.
That's cool.
Mm-hmm. Mm-hmm.
You guys see?
Mm-hmm.
It'll be cool if the groundwater goes like through a different place, and you can measure
Yeah,
that separately.
yeah, to separate out the groundwater from the surface. Yeah, I haven't seen any of those systems yet. So in that sense, it's an artificial water table, but that's okay. It's getting there. I can see the settling going on here. Look at that. It's just crazy.
So would that be one cause for error then? Because it's taking both runoff and the groundwater at the same time.
Yeah, there is. But once you start getting this, so now we've got groundwater flow coming out of the pipe. You can hear it dingle-dangling down there. But of course, that's what happens anyway under real river channels, right? The river is sustained by the base flow, and that's the water table anyway. So that's realistic.
So this wouldn't be flowing if it weren't saturated completely underneath, correct?
Correct.
Okay.
Yeah, correct. Because the infiltration rate on this artificial sediment is so high.
Okay.
But after a lot of experimentation between the developers of this, they've figured out the right ratio between the flow and the sediment sizes and the density of the sediment to make it all work. Alright, so we're getting there. No, I mean very little will come through there's a slit down in that PVC pipe, so a little bit will get out, but it's got to be. What are we doing on the height there? Ah. We're getting close. Struggling with this little alluvial fan here that it's. It really is remarkable how well this replicates erosion. Remember in class I was saying that you think of erosion as a kind of detachment, transport, and depositional process. And in large systems we tend to think of it as erosion on a slope and then transport by a river and then deposition in fans or whatever. I'll tell you in a sec. But those three are obviously going on all at the same time. Erosion, transport, and deposition. Wait until it breaks over the top. Got a stopwatch? Anybody else got a stopwatch? Not yet, not yet. Okay, has someone got a stopwatch ready?
Yeah.
Okay, let's do it at, we'll do it, I'll give you a 5-second countdown and then put it under and then start the stopwatch. 5, 4, 3, 2, 1, go.
For how long then?
We'll tell you in a sec.
Alright.
So we're doing this at 21 minutes and 15 seconds. You'll want to make a note of that. And we'll probably want to do it for 20 seconds. So you just give her a 3, 2, 1 or something.
We'll take it out
Now?
now.
Okay, cool. Alright, so that's your first data point. So you can measure that, you can pour the water into the tall beaker and we get a discharge rate over 20 seconds. I mean, there's a little bit of both, but this is predominantly surface water. So we get a bit of losing water here at some point. So just shout it out. No, try and keep the sediment out, that's great. I mean, there's going to be error as you see all along the way. If you get a volume in, and then this one, with such low sediment, that's quite useful. Just to do this. So just that in, and then check the quantity.
Take one.
Yeah, you're never going to get it all, right? Sediment in this is naturally 6. Okay, guys, so it's just going to call out the volume of water and the volume of sediment. How much? How much? 670. Perfect. So 670 milliliters over 20 seconds. And how many milliliters of sediment? 6. Bingo.
What was that?
You have a data point. 6 milliliters of, 670.
It went down to 40.
Thanks.
You need this again?
Yeah, you can just then rinse that out. There's a kind of rubber hose attached to the faucet there. And when you're done with the sediment, you can take it up and just empty it out into the tray. Not the big bucket, but this tray over here. So it all gathers. Alright. Then we'll do another one fairly soon, because now we've got the flow established. And even though, guys, it looks like it's established this kind of equilibrium link, it hasn't. It's going to be eroding and depositing all the time now because it's still not a completely smooth bed from there back to the runoff. Whoops.
A little bit less. It's actually getting closer. Yeah.
It's going to be, whoop, wow, it's pulsing here.
Yeah, that's fine.
It's looking pretty good.
Can you pour this out?
Yeah, you bet. Actually, if you poured it back in here, that'd be great because you don't want the pump. Ooh, I'll tell you what the issue is. There you go. Shoot. Oh, slow down. If you wouldn't mind grabbing,
It keeps on
filling that
falling
with,
down.
yeah, if you wouldn't mind grabbing some more water and fill that and start emptying more water into the. Sorry about that. We got a little pump issue here because that does happen. It runs out as I keep forgetting that the water infiltrates into the groundwater. You lose water. Yeah. Sorry about that. Oh. Yeah. If you guys can keep filling that, that'd be useful. Yeah, just pour it into the bottom there. That'd be great. Where are we on time? 26. What did we do at 21:15? Okay. Yeah.
Yes.
Keep going. That's great, thank you. Looking pretty good. Okay, so it's 27:11. I think we should do another discharge measurement at 30. 30 minutes.
So on average, where are you going to get the most erosion from along this channel?
Along the channel?
Yeah.
There's no specific area that is more or less erodible. Once it's really settled down, you get a lot of it around here. Sometimes it gets a lot of scour in and around this area here. But yeah, there's no. Yeah. It's jumpy up there. You're starting to get. What you'll notice, I know that again this is a little more kind of geomorphology than soils, but what you'll notice is this starts looking awfully like a real river channel with a bar here. Here's an old floodplain, and as it starts establishing its levels, it's going to start leaving these little meanders and abandoned terraces along the way. Okay, so it's 28:30, another minute and a half. Be ready? And we'll do one more normal one, and then we'll fiddle with the slope and we'll fiddle with the discharge. Another minute.
Seems to stop coming around here.
Yeah. Yeah.
I wondered if it was going to get to this over here or not.
It's still messing with this little depositional area here. And that you can see it's starting to establish the